little bit about how I use notebooks. I think it's very similar to everybody else, but it's really nice to share experiences. I actually use them both for the lectures, which are delivered with slides like these ones using Rise, and then also for workshops, which are in-person workshops. So very similar to the previous speaker. We really want everyone to be there. We want them to interact with the material, but then they can carry on and pick up exactly where they got to. And Notable is great for doing that. I find for the scientific machine learning type content that I'm delivering, interactive demos, I'll show you one in a second, really help to illustrate the points that I'm making. And the feedback in general is good. The students enjoy the notebooks. They get the lecture notebook that they can download as an assignment as well after the lecture, or I make it available during the lecture, so they can change the values, run code themselves for all of the examples that I show in the lectures, as well as using the same platform to deliver the workshops. This is a segment from a lecture. I picked something that may be familiar to some people who've done a little bit of data science. I'm explaining how the k-means algorithm works at this point in the lecture. It's a clustering algorithm. So I've been through a bit of mathematics, and I explain how it works. And so I make things like this, where I can change dynamically the amount of noise that I'm adding when I generate this data. I can skew the covariance to make my clusters that I'm generating a bit less spherical to start with, and make it hard for the algorithm to correctly partition between the blue and the green. In this case, you can see there's some mixing. And then in the lectures, I go on and I show a better way of doing it, which I explain properly and go through all the maths. And then I show that if you instead use Gaussian blobs to represent these clusters rather than just point estimates for the mean, then you can correctly separate things even in the presence of non-spherical things. So I kind of go through things from both directions. I explain all the maths, and then I show quite clearly what I've just explained with an interactive demo, which the students can take away and work themselves with afterwards. This is the instructor view in nbgrader, just because I wanted the answers in. Usually the student version would not have this metadata visible. So this is an example from an earlier workshop on linear regression. So I provide some stress strain data. It's for a molecular system. So I give them a visualization of what is happening. We're pulling a copper bar apart. It's getting stretched and breaking. And then they look at the stress versus strain, and it's got an elastic part, and then it goes very wiggly where it's plastic. And then I get them to write some code to do regression to fit. Everybody has to fit the easy part, the straight part, and then as an optional extension, you can also go on and try and fit the wiggly part as well, and think about what basis functions you would need to use to describe this part. So that's the kind of exercises that I get them to do. It works well as a balance between manually graded parts where there are plots and auto-graded parts where they have to compute numerical solutions. And I find that's quite time effective for me.